A flight simulator is a device that artificially recreates aircraft flight and the environment in which it flies, for pilot training, design, or other purposes. It includes replicating the equations that govern how aircraft fly, how they react to applications of flight controls, the effects of other aircraft systems, and how the aircraft reacts to external factors such as air density, turbulence, wind shear, cloud, precipitation, etc. Flight simulation is used for a variety of reasons, including flight training, the design and development of the aircraft itself, and research into aircraft characteristics and control handling qualities. History of flight simulation. World War I. An area of training was for airgunnery handled by the pilot or a specialist airgunner. Firing at a moving target requires aiming ahead of the target to allow for the time the bullets require to reach the vicinity of the target. This is sometimes also called deflection shooting, and requires skill and practice. During World War I, some ground-based simulators were developed to teach this skill to new pilots. The 1920s and 1930s, the best-known early flight simulation device was the Link Trainer, produced by Edwin Link in Binghamton, New York, USA, which he started building in 1927. He later patented his design, which was first available for sale in 1929. The Link Trainer was a basic metal frame flight simulator usually painted in its well-known blue color. Some of these early war-era flight simulators still exist, but it is becoming increasingly difficult to find working examples. The Link family firm in Binghamton manufactured keyboard organs, and Ed Link was therefore familiar with such components as leather bellows and reed switches. He was also an amateur pilot, but dissatisfied with the amount of real flight training that was available. He decided to build a ground-based device to provide such training without the restrictions of weather and the availability of aircraft and flight instructors. His design had a pneumatic motion platform driven by inflatable bellows which provided pitch and roll cues. An electric motor rotated the platform, providing yaw cues. A generic replica cockpit with working instruments was mounted on the motion platform. When the cockpit was covered, pilots could practice flying by instruments in a safe environment. The motion platform gave the pilot cues as to real angular motion in pitch, roll and yaw. Initially, aviation flight schools showed little interest in the Link Trainer. Link also demonstrated his trainer to the U.S. Army Air Force, but with no result. However, the situation changed in 1934 when the Army Air Force was given a government contract to fly the postal mail. This included having to fly in bad weather as well as good, for which the USAAF had not previously carried out much training. During the first weeks of the mail service, nearly a dozen Army pilots were killed. The Army Air Force hierarchy remembered Ed Link and his trainer. Link flew in to meet him at Newark Field in New Jersey, and they were impressed by his ability to arrive on a day with poor visibility, due to practice on his training device. The result was that the USAAF purchased 6 Link trainers, and this can be said to mark the start of the world flight simulation industry. World War II. The principal pilot trainer used during World War II was the Link Trainer. Some 10,000 were produced to train 500,000 new pilots from Allied nations, many in the USA and Canada because many pilots were trained in those countries before returning to Europe or the Pacific to fly combat missions. Almost all U.S. Army Air Force pilots were trained in a Link Trainer. A different type of World War II trainer was used for navigating at night by the stars. The Celestial Navigation Trainer of 1941 was 13.7 meters high and capable of accommodating the navigation team of a bomber crew. It enabled sextants to be used for taking star shots from a projected display of the night sky. 1945 to the 1960s. Indiana. 1954 United Airlines bought 4 flight simulators at a cost of $3 million from Curtiss-Wright that were similar to the earlier models, with the addition of visuals, sound and movement. This was the first of today's modern flight simulators for commercial aircraft. Types of flight training devices in service. Training for pilots. Several different devices are utilized in modern flight training. Cockpit procedures. Trainers are used to practice basic cockpit procedures, such as processing emergency checklists, and for cockpit familiarization. Certain aircraft systems may or may not be simulated. The aerodynamic model is usually extremely generic if present at all. Technology. Motion in flight simulators. Statistically significant assessments of skill transfer based on training on a simulator and leading to handling in actual aircraft are difficult to make, particularly where motion cues are concerned. Large samples of pilot opinion are required and many subjective opinions tend to be aired, particularly by pilots not used to making objective assessments and responding to a structured test schedule. For many years, it was believed that 6DOF motion-based simulation gave the pilot closer fidelity to flight control operations and aircraft responses to control inputs and external forces, and gave a better training outcome for students than non-motion-based simulation. This is described as handling fidelity, which can be assessed by test flight standards such as the numerical Cooper-Harper rating scale for handling qualities. Recent scientific studies have shown that the use of technology such as vibration or dynamic seats within flight simulators can be equally as effective in the delivery of training as large and expensive 6DOF devices. Qualification and approval. Procedure. When a manufacturer wishes to have an ATD model approved, a document that contains the specifications for the model line and that proves compliance with the appropriate regulations is submitted to the FAA. Once this document, called a qualification approval guide, has been approved, all future devices conforming to the QAG are automatically approved and individual evaluation is neither required nor available. Flight simulator levels and other categories. The following levels of qualification are currently being granted for both airplane and helicopter. FSTD. U.S. Federal Aviation Administration Flight Training Devices. FAA FTD Level 4, similar to a cockpit procedures trainer, but for helicopters only. This level does not require an aerodynamic model, but accurate systems modeling is required. FAA FTD Level 5, aerodynamic programming and systems modeling is required, but it may represent a family of aircraft rather than only one specific model. FAA FTD Level 6, aircraft model-specific aerodynamic programming, control feel, and physical cockpit are required. FAA FTD Level 7, model-specific, helicopter only. All applicable aerodynamics, flight controls, and systems must be modeled. A vibration system must be supplied. This is the first level to require a visual system. Full flight simulators. FAA FFS Level A motion system is required with at least 3 degrees of freedom. Airplanes only. FAA FFS Level B requires 3-axis motion and a higher fidelity aerodynamic model than does Level A, the lowest level of helicopter flight simulator. FAA FFS Level C requires a motion platform with all 6 degrees of freedom, also lower transport delay over levels A and B. The visual system must have an outside world horizontal field of view of at least 75 degrees for each pilot. FAA FFS Level D, the highest level of FFS qualification currently available. Requirements are for Level C with additions. The motion platform must have all 6 degrees of freedom, and the visual system must have an outside world horizontal field of view of at least 150 degrees, with a collimated display. Realistic sounds in the cockpit are required, as well as a number of special motion and visual effects. European Aviation Safety Agency Flight Navigation and Procedures Trainer EASA-FNPT Level 1, EASA-FNPT Level 2, EASA-FNPT Level 3, MCC, not a true level of qualification, but an add-on that allows any level of FNPT to be used for multi-crew coordination training. Flight training devices EASA-FTD Level 1, EASA-FTD Level 2, EASA-FTD Level 3 Helicopter only. Full flight simulators EASA-FFS Level A, EASA-FFS Level B, EASA-FFS Level C, EASA-FFS Level D. Modern high-end flight simulators. Vertical Motion Simulator at NASA, Ames. The largest flight simulator in the world is the Vertical Motion Simulator at NASA Ames Research Center in Silicon Valley, south of San Francisco. This has a very large throw motion system with 60 feet of vertical movement. The heave system supports a horizontal beam on which are mounted 40 feet rails, allowing lateral movement of a simulator cab of plus or minus 20 feet. A conventional 6 degree of freedom hexapod platform is mounted on the 40 feet beam, and an interchangeable cabin is mounted on the platform. This design permits quick switching of different aircraft cabins. Simulations have ranged from blimps, commercial and military aircraft to the Space Shuttle. In the case of the Space Shuttle, the large vertical motion simulator was used to investigate a longitudinal pilot-induced oscillation that occurred on an early shuttle flight just before landing. After identification of the problem on the VMS, it was used to try different longitudinal control algorithms and recommend the best for use in the shuttle program. Disorientation Training AMST System Technik GmbH of Austria and Environmental Tectonics Corporation of Philadelphia, U.S. manufacture a range of simulators for disorientation training that have full freedom in yaw. The most complex of these devices is the Desdemona simulator at the TNO Research Institute in the Netherlands, manufactured by AMST. This large simulator has a gimbaled cockpit mounted on a framework which adds vertical motion. The framework is mounted on rails attached to a rotating platform. The rails allow the simulator cab to be positioned at different radii from the center of rotation, and this gives a sustained G capability up to about 3.5. Amateur and video game flight simulation.